Today we'll be solving question number 2 on page 79 in the textbook. A 62 kilogram rock climber is attached to a rope that is allowing him to hang horizontally with his feet against the wall. The tension in the rope is 7.1 times 10 to the power of 2 newtons, and the rope makes an angle 32 degrees with the horizontal. Determine the force exerted by the wall on the climber's feet. First, you would state the givens and draw a free body diagram. You are given the mass, which is 62 kilograms, the force of tension, which is 7.1 times 10 to the power of 2 newtons, an angle, which is 32 degrees, and the acceleration, which is 9.8 meters per second squared with the direction downwards. This is the acceleration because we assume that we're on Earth. We're trying to find the force exerted by the wall on the climber's feet with direction. Second, you would solve only the y components. To find the force of gravity, we take the mass times acceleration, which gives us 608.2 newtons. Then we find the y component of the force of tension. Since it's a right angle triangle, we know that we could use the tension of the rope times sine theta. This gives us 376.2427 newtons. To find the total value in the y components, we add the two components together. At this point, we establish up is positive and down is negative. Therefore, force of gravity is negative. This gives us a final value of negative 231.9773 newtons in the y components. The third step is to look at the x components. The force in the x component is the x component of tension, and this is the only force in the x component. To find this, we use the force of tension times cos theta, which gives us 602.1141 newtons. Since we established that left is negative and right is positive, the total value in the total force in the x component is positive. Finally, we put everything together. The x and y components form a perfect right angle triangle. Therefore, to find the net force, we would use the Pythagorean theorem. Isolating for the net force, we get a value of 645.2628 newtons, or 6.5 times 10 to the power of 2 newtons. However, we still haven't solved for direction yet. To solve for direction, we would solve for gamma. Solving for gamma and using the trig function, tan gamma equals the total y components divided by the total x components, gamma will equal 21 degrees. And as you can see, the final red vector is in the direction in the left up direction. In conclusion, the force exerted by the wall on the climber is 6.5 times 10 to the power of 2 newtons, left 21 degrees up.